I think we're going to go ahead and get started. So I'm Evan Powell from Nexenta Systems, and first off I want to say thank you to everybody in the audience for coming, not just to this panel, but to the whole few days. It's pretty amazing if you think back a few years. The first show was actually here, and we could have all fit, well, we did fit in a room about this size, so it's grown a lot. And secondly, I want to say thank you to the panel. I think this is similar to the panel I did yesterday, where we have more brain power than we have time. But really excited about the group of folks who are sitting to my left here. And the way we're going to run this panel is we're going to start by not doing the panel. We're going to start by actually a hands-on, real-world experience with a particular vendor of software-defined storage, but to give you a concrete example, even some data, some numbers from our friend Christian at Intel. We're going to do that for however long he wants, but probably 20, 25 minutes.
Tops.
Yeah, and then we're going to dig into what do we think software-defined storage actually is. And I'm going to try to find, I'm here as a panelist, not as a advocate for one or the other definition. So we're going to try to find some common ground and some ways to disagree. So as Christian goes through his presentation, I think it'll spawn some more questions. We're going to ask questions at the end of his presentation, but then also keep some good controversial stuff to get us to, disagree about something. Because I think about a lot of things, we're probably in violent agreement. So with that, again, thank you for coming, and I'll kick off, I'll hand off to Christian.
Thanks.
Yep.
Hey, folks. I'm going to talk a little bit today about what we did with a virtual machine data store using Nexenta's product and ZFS and the Intel 3500 series standard SSDs. You guys know the drill on that. We'll talk about a little bit who am I, where did I come from. I've got a brief marketing pitch about the data center family of drives from Intel. I'll tell you about our hardware, how we constructed things, how we set it up, some testing results, and a little bit about our BKMs, or best known methods. Ooh, that sounds really loud to me. And talking about your workload, right? Your workload really matters. How you construct your storage, when you're constructing your own, when you're using software-defined storage with specific hardware and specific drives underneath it, right? Whether those drives are solid state or whether or not they're spinning rust. Your workload matters, and how you construct that is really, really important. So a little bit about me. I started on an Atari 400 back in 1980. I also started my IT career in the Air Force, changing 12-inch platters on a Wang VS, if anybody's remembering. I did a few years in the Air Force, and then I've worked in IT basically ever since I came out. A brief summary of our data center drives at Intel. We make a PCI Express drive. This is a 800, all of them are up to 800 gigs in size. The PCI drive shows up as 4 logical volumes at 200 gigs apiece. And there's a whole bunch of different speeds and feeds there. These are meant for enterprise. They've got the endurance, they've got the reliability that you'll need for that. The only thing I really want to point out in terms of features is we do power loss imminent protection. So if your server unexpectedly loses power, the drive has enough onboard super cap to drain all of the caches and make sure that everything's written out to NAND. We take a little bit of hit in top-end I/O in order to make sure that we maintain consistent performance for everything. So as you put these drives in RAID sets behind RAID controllers in your data center, you're not going to get the type of poor scaling that you see with solutions that have wide variations in their I/O response. We do 256-bit encryption, and then last but not least, full data path protection. So there's data path and non-data path protection for all your data, so you don't have to worry about bit errors. So a little bit about the solution that we put together for this. Basically, we took one of the Intel, what we call our EPSD platforms, Xeon 2690s, S2600 CP motherboard, 128 gigs of RAM, basically 24 drives in a 2U chassis, what you would see as a kind of standard, substandard storage server, and then put a couple of LSI controllers in there, and a 10 gig dual port NIC. On top of that, a couple of VMware hosts on the side, ESX51. We didn't repeat this testing with 5.5 yet. Again, E5 2690, 120 gigs of RAM, and for this particular test, we use the Supermicro Fat Twins. Those are really nice little chassis to host our VMs. And we ran 48 VMs, 12 VMs per host, against NFS target on the Nexenta software-based SAN. So a couple of things that we learned in the process. The Intel solid-state drives are built for 4K block. So you need to make sure that you don't write blocks that are smaller than that. So we made some changes in SDConf to tune the block size to 4096, set the queue depth to a max of 32 with throttle max, turned IO coalescing off with the disk sort false, and then turn the non-volatile cache on the drive, because we have that power loss interrupt feature. We can turn that on. 2 Z pools, six drives apiece, one on each controller, and then we turn dedupe and compression on. And typically for your solid state drives, right, you're going to want to set your IO scheduler to no op or deadline. You're going to want to turn your RQ affinity to 2, which lets the OS distribute the interrupts. 4K block size and offsets that are divisible by 4096. And then for our SSDs, if you look at the Smart Mon tools in Linux, or I think it was Smart CTL in Illumos and Open Solaris, if you look at the E9 Smart Stat, that gives you a little gas gauge. It's a wear level indicator for our solid state drives. It'll give you a 99 to 1, and it basically counts down your gas gauge as you use the drive. So it'll tell you how long your workload's going to last in that particular thing. So again, 4 hosts, 12 VMs per host, and during the testing we observed roughly a 70,000 IOP barrier for each individual host. So we weren't capable of driving, no matter how many VMs we put on a box, more than about 70,000 IOPS per host. And what we really achieved with those 4 boxes is 100,000 random IOs at 4K. And that was an average of 3 test runs at 1.5 hours per test run, right? So this is repeatable. Everything in the system has flatlined and stabilized. 9010 read-write workload, 4 queue depth, 48 VMs, and an average of 2.5 milliseconds latency. So with a pure solid-state storage of only 12 disks, standard endurance disks, we're able to deliver 100,000 random mixed IOPS with this solution, and it costs about $30K total. So roughly a third of the cost of a traditional SAN, and quite frankly, it's kind of tiny. I mean, it's 2U and about 650 watts when it's cranking full bore. So it's not really a terribly power-hungry solution. And we got another 12 slots in the box, and we weren't pegging the processors yet. So there's actually room to grow there, as long as you don't exceed with those particular VMs that 8 terabyte footprint. The cool part about the Nexenta is they offer that inline dedupe, and our compression ratio on the base disks was basically 48 to 1. Right, so the only thing that actually expanded the use of the system was the 2 gig drive that we were using as the target for I/O. So with those 100,000 results, or 100,000 IOP results, knowing your workload is really important. We're starting to build our own SANs. Right, we're starting to build our own software-defined storage. When we start doing that, we really have to be aware of our workload, and we need to do the job that we formerly got from the large traditional storage vendors ourselves, or have an integrator help us with it, or have a software company like Nexenta help us with it. It's really important to know your workload, how it's distributed, what type of block sizes it uses, whether or not it's read, whether or not it's write, whether or not it's sequential, whether or not it's random. Obviously, if you have a bunch of virtual machines on top of a data store, you've got a blender up there at the top generating I/O, and you need to provide that as many random IOPS as you can. So getting to know your workload, getting to know what your drives will do and what your solutions will do, and then picking the right drives and the right software for your use case is really, really important. It's very possible that this particular solution, we didn't use a ZIL, and we only used memory. So we probably could have inserted some sort of PCIe flash here for either ZIL or the ARC-L2, and we could have also used something like a Zeus RAM or a higher end RAM-based drive for that ZIL also. So as you look at doing these storage solutions, and as you look at building out in your data centers storage solutions based on the hardware that you select and the drives that you select and the network that you select, right? Keep the Intel SSDs in mind. They're fantastic products. They're well positioned for the data center. They're SATA, so there are limitations there as opposed to SAS. Be aware of those, and if you have anything really interesting coming your way, contact either myself or Scott Doyle. We're over at the Folsom campus. I'm in charge of the big data and HPC space, and Scott's in charge of cloud and virtualization. So that's about it. Any questions? Cool. All you.
Okay, so what is software-defined storage? As we've just seen, it can be all flash and pretty fast with pretty low power. But what I'd like to do is get the panel to introduce themselves and talk a little bit about who are they and what does their company do. And I think you're going to see that we all view software-defined storage from a slightly different perspective. And again, thank you all for being here. So Joe, take it away.
Well, thanks for the opportunity, Evan. So my name is Joe Arnold. I'm the CEO of SwiftStack, and what we do is we provide a object storage system that's built on top of OpenStack Swift. And actually, ironically, we have a book that we put together around software-defined storage where we take our own stab at the definition. And we have a few copies up here if any folks are interested.
Will you sign them? Or
So the way we think of software-defined storage is the nature of the controller is changing. And instead of being in the packet path, the controller, when you have a software-defined storage system, you're actually building out a system that spans across lots of different nodes, lots of different zones in a data center, lots of regions. So you might start having different links that are connecting a bunch of different storage nodes together as a whole. So the notion of a controller starts to look more like a software-defined networking controller, where it's telling the system, the distributed system, here's how to behave, here's how to store data, here's how to do data placement. And then the system can operate and know how to route around failures to serve data requests. Probably didn't say, but should have said, of course this means the separation of hardware and software into its own independent elements. But that's the lens that we see software-defined storage.
Perfect. Great start. Neil.
So I'm Neil Levine. I'm the VP of Product for Inktank, who are the sponsor and major contributor to the Ceph project. Ceph is a unified storage platform for object, block, and file. So the object, S3, Swift as well. Block integrates Linux kernel, hypervisors, and distributed file system is POSIX compliant. We have as many inside our company. We have about 42 employees and about 43 opinions about what software-defined storage is. But like Joe, we agree it's a separation of the control plane. This is predominantly because we want to see as much of the storage defined by software. We think that the storage optimization should be done by software, the storage provisioning should be done by software, and so on. We want to try and get as much out of the brain of the admin and into the software as possible. So definitely part one. Part 2 is obviously the separation of the hardware and the software. I don't think there's something that's the most intrinsic element. It almost goes without saying. But I'll add 2 additional definitions. 3, we think it should be distributed. We think there's no point in introducing a brand new term which is going to confuse the market, confuse customers, unless it's something really substantially different. And I think for us, it's obviously somewhat self-serving, but we really think if we're going to introduce a new term, it's got to involve some major shift in the architecture, and that architecture is a distributed system now. So Ceph, like Swift and others, is very much scale out, not scale up. And the 4th piece, I think, is disruption. Again, if we're going to really change this thing, change the storage industry, change how people and customers engage with storage platforms, it's got to touch everything. It's got to touch as much of the stack as possible. It's got to change the economics. It's got to change the operations. We really want to change how software is written and used and deployed on top of storage too. So it's a little bit like pornography, the definition. Nobody knows quite how to define it, but they know it when they see it. And I think for customers, if they see a software-defined storage system, it's really got to feel substantially different, both on the bottom line and in the operations. And that's the fuzzy edge, which I think confuses people. That's me.
My name is Ben Wu. I'm the Managing Director of Neuralytix. We're a market research company. It's a global market research and consulting company. I disagree with these guys a little bit. There's no surprise for most of you for me to disagree with this. We define software-defined storage as a piece of software that can be instantiated either in the server or on an appliance, which facilitates the functions, the storage functions of provisioning, orchestration, monitoring, and management across and between a federation of servers and a federation of storage devices. So what I also disagree with Neil on is that we're not changing the storage industry. The storage industry has been around for 35 years. I've been around that storage industry for most of that time. And I can tell you the one thing that storage people don't do is change, at least not change very quickly. What we're seeing with software-defined storage is an evolutionary step in which we're moving from a traditional infrastructure focus around pieces of hardware that tend to be self-standing to being a much more of a services play. Much like cloud is today. We took what was on-prem and we shoved it somewhere else, changed the economics, which I do agree with, right, and made it available in new ways. There is nothing that changed behind the scenes other than the way we're presenting storage. Block will always be there. Block has to be there in order to write the ones and zeros. Somewhere along the data path, there will be block, right? But I do also agree, though, that this is not a data path consideration, this is a control path consideration. And as a result, what you end up with is it's an abstraction, a new abstraction layer to storage, as we've seen it before. We started with disks and went to RAID. We took RAID and we stuck several RAIDs together and abstracted that. We took several of those systems, we linked it together behind some storage virtualization box. And now we're going to take that one step further and saying, hey, you know what? We can go multi-geo, multi-clusters, multi, and oh, by the way, has a singular interface. And that to me is what SDS is all about.
So hold those thoughts. No, that was great. I mean, my fear was we're all going to be in violent agreement, and I'm not sure we're going to be, which is good. Okay, Fons.
So I'm Fons Kessen from Schuberg Philis, where I'm a mission critical engineer, and I'm one of the cloud architects there, principal cloud architects. We've been running SDN for about 2 years, working together with the guys from Nicera. We were the second customer in the world to go live with them. And I have a bit of a different view than you guys have in certain aspects, and in certain aspects I can violently agree with you. I think software-defined storage is all about, there's an API you talk to on a control plane which is separated from your data plane. I don't care what your protocol is underneath that or how you do that. That is irrelevant. It's not relevant. The only relevant is that you've got a data plane, and you've got data storage, and you've got a control plane, and an API to talk to it. That's, to me, software-defined storage. That I can offer it, and make policies, and enforce those policies on storage I give to nodes, be it virtual nodes, physical nodes, or whatnot. And that's my view on it.
We actually agree.
Wow.
We're cool. We're see about that. Okay. Christian. I don't think we disagree. Well, go ahead, please.
So just in general, obviously, Intel's a little agnostic about this as a whole. We try and play everywhere nice.
It should be interesting. Let's see
But
how this goes.
my old IT brain, and after 23 years in enterprise IT, right, software-defined storage is kind of scary. I don't know how many people here in the audience are from enterprise IT shops that were in ops, right? Right? All you put up your hands, right? This is scary. You're building your own SAN. And when you separate those planes, that's great, but how well does it perform, and is it going to fail, and how do I develop the skills to deal with it, and how do I prove it over a certain amount of time, right? So for me, software-defined storage is much more about the becoming familiar, attaining maturity, and then being able to use that maturity to forward my business.
But you're seeing it from like a storage device perspective.
Yep.
Okay.
How many people actually have operated the VAX or worked on the VAX?
The VAX?
Yes.
Yes.
All right, you guys remember what a CI cluster is? Oh, now I'm sure. CI clusters were invented in the early 70s, and that essentially is what a SAN is, and that's essentially what software-defined storage is.
Was that CoView?
I'm sorry?
Was that CoView?
CoView?
Isn't that what it was called?
No, it was a DEC interface that died very, very slowly after the digital folded. But I know that we want to say that this is all brand new and fun and so forth. When we think about the x86 world, we're just repeating the sins or the history of a world that we've already been through. Like I said, I don't think storage people change that much. We like to reinvent things and rename things. But a lot of the technologies and ideas, and I won't say the technology, let me take that back. A lot of the ideas and concepts in which we're talking about here, about tomorrow and about today, have actually been done in some form and way before, just under a different name with different performance metrics.
I don't disagree, but it's not up to me. Let's hear what Dmitry has to say.
Sorry, Dmitry, sorry.
It's actually very good. One more. Yep. Right.
We wanted to abstract away the chairs, by the way.
Right.
But Dmitry didn't agree to squat the entire time. So he's still reliant on hardware. So.
Oh, yeah.
Just think of him as virtually squatting.
Yeah, I can disagree. Actually, you're right. You're absolutely right. We have, 7 people here, and we have a different opinion. I think what happened, EMC Viper actually confused everybody in the room and here as well. I'm sure you guys all do not know exactly what software-defined storage is. So as being an engineer and founder of Nexenta Systems, I'm trying to figure out what is the statement. Can I come up with a concise single statement which can define? In my head, and maybe you guys would disagree with me, in my head, software-defined storage is simply about implementing storage functions in software and not relying on hardware in any shape and form. Be agnostic to hardware. Right now, what we do on object side is great. What we do on the things we've done in Nexenta on block and file is also great because we managed to separate this. We managed to run the enterprise NAS and SAN devices on top of a variety of x86 platforms. That is to me what software-defined storage is. I don't know if you guys disagree with me.
But then the issue is why we just call it storage software. There's something intrinsic about calling it software defined, which seems to separate it out from. The storage software has been around a very long time. Most of storage has always been in the software. But it's the point. If this is what if we're introducing a new term, there's got to be a reason for it. There's no point having this term and then trying to assign sort of value and meaning to it. It has to represent something.
Well, Neil, as an analyst, I can tell you there is a point to giving a term to it because it's a new market that analysts can count.
Exactly. It's a new thing for vendors to push as well.
Exactly. I think there are a couple of things that we need to remember. There is storage software that can sit in a server such as Veritas or Semantics VXFS and the functions that they have. That's one type of storage software. Right. Then there's storage software that sits that is inside the controller of a storage system. All right. Now, the definitions and the nomenclature I'm using is highly academic because that's how analysts want to put
but
things.
the thing is, it's not just about calling it that. There's actually, to say that we've been doing the same thing is absolutely not true, because the workloads that we're doing today are fundamentally different, right? Because today we're actually building different applications. We're still serving
We're still
like
serving
web applications.
CRM, and we're still doing finance.
Sure.
These are the same things that we've been doing on both mainframes and mini computers for years.
The customers that are coming to us they have to. It's not because, they want to come to us, but more to the point, they have to come to us because the architectures of these distributed storage systems are the only way to deal with the workload, to deal with the amount of storage that they're ingesting.
But without running ridiculous costs. That's the whole point.
Correct.
Well, hang on, the economics have changed. I think that we all agree with that.
Or injecting the complexity into the application, which is the other thing we're seeing.
Exactly.
So people set up these SANs and they scale out, or they scale to a tremendous amount of IOPS, but then the application has to get smart and go, oh, this user goes over here, this user, you go over there, this user, you go over there. And then the operations team, suddenly they have an operational nightmare just interfacing between the different levels of the organization. So that, I think, is the problem that software-defined storage is
That's
solving.
storage management software, though. I mean, ultimately...
It's not management. That's not management. We're in the data path.
Well, hang on. I want to make one note here, which is that a lot of these panels and a lot of these discussions are with people who are not natively from the storage industry. Right, but they're not necessarily guys who grew up with disk drives and so forth. And you guys are taking a very different view in terms of the
You're
way
making a lot of assumptions there. I'm sorry. Come on, really. I'm sorry. You can't say that. You're making too many assumptions about who we are and what we do.
Let's pull it back. I think we've all spent our fair share of nights in the data center floor.
It's all about the data center floor, fellas. And
But let's pull it back slightly, if you don't mind. So we're hearing a few different, I think, fissures, or maybe I'm projecting, but one is the data path. I mean, you mentioned, because that does potentially distinguish all of us from, from Viper, for one thing. And secondly, another would be scale up, scale out. And I ask you guys to keep these thoughts in your mind. So what's another one? There's at least two. There's probably a third we were talking about.
I think that if I may hijack the conversation a little bit.
But talk data path. I mean, do you think that absolutely software-defined storage is differentiated, let's say, from a Viper or an Uber manager because you're actually touching the data? Is that fair, and we agree with that? Or, I mean, other than you, Ben, do we agree with that?
I think the funds agrees with the fact that this is a control path conversation.
Yeah.
Okay, fair enough.
Here's the point. I think from our perspective, when we talk about economics, separating it from the hardware gives you another boost to the economics as well. So just making it control plane gives you lots of operational changes. But if you're, again, when we talk about disruption, sure, storage evolves and will continue to evolve. But if you're looking to make a radical shift in the economics, like a 10x shift in the economics, the separation of the data plane does allow you to do that. It does free up.
But that's exactly what we're saying. That's exactly what I was saying. I want the control plane separated from the data plane. I would have separated.
I have one observation. I think because of software-defined network, and I find this group, the storage group, try to jump on that same bandwagon, like say data plane, control plane. Now in the network world, control plane is well defined, standardized. You talk to vendor A, vendor B, they talk about the same standard.
Actually, they don't. That's not true.
The option may be different. However, in the storage world, I don't know when you talk about the control plane. You talk to 100 people, 100 people give you 100 different definitions.
No, but
Control. What you mean is really the management, not the control.
Correct.
no, but that's the control plane. It's the same thing. The management plane is the control plane. It's where you control stuff with.
So when you say management, then you have to say, what are you managing? Provisioning, performance, fault?
Provisioning, orchestration, monitoring. Those are the things. That's what I mean, I don't know that we're going to disagree on this point. We're talking about the provisioning of storage. We're talking about the orchestration of that storage to be delivered based on certain criteria, whether it's capacity, performance, or cost, right? We're talking about monitoring that and making sure that is actually working, and actually putting something together from a classic management view that says, okay, here's a GUI to go do it.
That's a very good definition. However, the problem I see is that no industry-wide agreement of that should be defined. Those things should be the control.
But with SDN, there isn't agreement either.
You should go and have a look at the cloud market. They're still trying to argue about what cloud means over there. That's still a multi-billion-dollar business here. I think the problem I think we have is we can have our own definitions of software-defined storage, but this is a very inward-looking sort of academic, how many angels can dance on the head of a pin kind of conversation here. The problem is, and I think this was alluded to in the presentation, was that it's confusing customers. It's basically the message they're getting is that software-defined storage means I have to do more, I have to worry about more that traditionally I didn't worry about before. And that for me is the biggest problem we have with software-defined storage. I think we can continue to argue around the definition, but it should be making stuff easier for customers, better from the economics, easier from the operations. And so rather than trying to agree on, find the things we agree about, control plane, data plane, and there's a loose set I think we can more or less agree about. But it's like, well, how do you make this easier for customers? What does this mean in terms of how they buy hardware? What does this mean in terms of how they provision stuff and then manage it? And this is
that's what I think
guys,
we're all collectively doing that.
You can't just say here's a bunch of disk drives and all of a sudden magically it happens. It doesn't happen
exactly.
that way.
I know, but it's the point.
So let me make that suggestion. Let's see. So the panel's going a different direction. I thought we'd all agree. Now we have too much disagreement. So can we? Well, we have had some agreement. So in part because we only invited, the only people at the Open Storage Summit are people that take an open approach. So, but I think we all probably agree software-defined storage has something to do with abstracting away from the hardware.
Yep.
And to your point, that there's a big value proposition there, right? Because storage is a mess, right? If you saw the keynote yesterday. But anyway,
getting that out there in the environment, it's really important to alleviate that fear that you're talking about, that it's going to be harder and it's going to be more difficult and it's going to take more engineers. Alleviating that will help.
And that's where I think we're starting to debate, or are debating in part, is how do you, so software-defined storage, and you abstract away the hardware, we would argue you have to have flexibility so you can handle multiple workloads, but there's we could debate that. But the third thing is you have to be able to be defined by software, and there is debate over what the control plane is. I think there is an SDN as well. But at least we agree on abstraction and being able to do you think anyone disagree with that and being able to abstract away the hardware? Okay. So if there's any press in the article in the room, you can see that we all disagree with EMC. Okay. All right. Because
I've got to put it on the table. I don't disagree with them. As the job that I have to do is accept that they are marketing something. They've decided to put themselves in this.
We welcome them. Hey, come on in.
Put themselves in this hat, and I'm not prepared at this point to suggest that they're wrong.
No, but you would say it's lipstick on a pig, right? I would.
They have certainly brought out a new piece of software, which is a Gen 1 Rev 1 piece of software, and their approach is that they also, AMC recognizes that the traditional modular and monolithic storage system as we know it is going to change. It's not going. People aren't going to be necessarily buying that.
How does it differ from Navisphere then? Navisphere was a unified CLI and GUI where you could manage all your EMC-based storage.
There was no capability of provisioning or orchestrating from Navisphere.
Actually, there was, yes. That's not true. There is. I've used it.
But it's not. The difference here is that it was controlling the storage systems and provisioning within the storage system, not providing that provisioning towards from a singular perspective across a federation of storage systems. So it was only available on EMC branded solutions.
Yes, exactly.
So we need to be able to find solutions that do that job across other systems as well.
I totally agree with that. So how is Viper different?
Viper is an elevation of that solution to include third-party software. At
some
the very
point.
least, that is the marketing approach.
That's the positioning.
Right.
That's positioning.
Yep.
So what is going to emerge to do the software defined? Maybe that's a question that I could ask each of you guys. So who are you being defined by? Where are you getting those inputs, Joe?
Yeah, well, so for us, I mean, the management is important, and it's an integral part of building out these systems. But the management is there to define, help to orchestrate across many nodes, across multiple networks. But fundamentally, that storage system is there to service user requests. So you can pile a bunch of, I hate to use the word random hardware, but random hardware, and then lasso around storage policies around different groups of that hardware, so that data can be placed in whatever policy that those users want.
Yep. I'm not disagreeing with that at all. I don't think anyone's...
Nobody's disagreeing with that.
But where does that policy intelligence lie today, or is it a true mishmash?
I think that's going to be in each of our respective systems on how we define that and the use case. And I think what's going to be different is there's not going to be, software-defined storage from vendor A, vendor B, and we're all competing against each other. There's actually a lot of use cases out there, and there's going to be, just like in storage systems today, so software-defined storage for use case X, for Y, for Z. We're all going to have our workloads that we're going to excel and be really good at, and go after those markets.
The thing I'm missing, though, in the whole story is that there's no unification in the sense that there's an agreement on there should be a way that you can control every storage component. So if you look at what was really brilliant about what the guys from Open vSwitch did was they introduced OVSDB, which you can talk to with OpenFlow. Now everybody's picking that up and is implementing it themselves. Arista is, F5 is, all these others are picking it up and implementing it. So there's coming a unified way of talking to a switch and triggering a switch or load balance or whatever to do something.
But it's kind of like, it's more of like a database analogy, though. It's like sometimes you want to use Cassandra, sometimes you want to use a...
No, it's not database analogy.
It's for storage, because there are fundamental differences, and I think in the data center we're going to go less generalized, and we're going to be more specialized. And the reason is because the storage footprints are getting larger, because more and more people are using applications that are running in a data center somewhere rather than in a data
But that's
closet.
a totally different discussion. My point is that I want to be able to control my storage device, be it my NetApp, my EMC, or my Nexenta, or SwiftStack, or whatever, or Ceph, from a central control plane and say, well, I want to offer this storage to this device right now. I want to offer this to this device.
What you're looking at, you're looking for standardization of the control plane API or protocol is what you're looking for, which is...
And it will never happen. It will never happen.
If we keep disagreeing, it will never happen.
Well,
exactly.
No,
That's just a
hang
hard
on.
thing to do.
This is how storage companies make money, though. Think about this. If whoever owns the storage owns you as a customer, period. What is it that we all deal with on a compute basis? Data. Whoever is
I don't think so. Well, look, I have to earn my customers every single time a contract comes up, because we're fundamentally based on an open source project.
Yeah.
I know, but
Every time.
But if your customer is bought into OpenStack and Swift, then it is extraordinarily hard to move away from that.
But
extraordinarily
it is an
hard,
open
and
source project.
It doesn't matter, but
but
they're
with
bought
us-
into it, you know.
Yeah, they can just not renew the support, and they don't have to move the data.
I'm not
it's open
disagreeing with
source.
all of that, but I think that one of the things we have to look at...
Not that
here-
they should do that.
Right, no, and I'm not suggesting they should. But what I'm saying is, again, if you look at the storage market, it's been extraordinarily slow, partly because of the fact that people don't want to migrate data. That's number one. And number two, there is a fundamental difference, I think, between the network market and the storage market. In the storage market, we track around 50 companies that make up 97% of the market. And then if you go into the flash market, last time I looked, there was 115 individual flash manufacturers. So there's a lot of, what's the word I'm looking for? Fracturing of the market itself.
There's less concentration,
Right,
massively less.
Exactly. And as a result, I think trying to get everybody on the same page, and I think if you take a look at SNEA, the Storage Networking Industry Association's attempt, what you end up with is common denominator that really doesn't do a hell of a lot. So I think that's part of the problem.
No,
But Neil, I think Neil was going to say something.
I agree with that point, but like somebody just said, S3, everybody's adopting S3. And that's only a way to place data.
Right.
To stay away from that for a second. But if you look at what happened in the SEM world, Open vSwitch was created, Nicira was done, and they actually were disruptive. They were really disruptive. They took the market and shook it upside down from the stairs, and all the bucket chains was falling out, literally. They were bought by VMware, and now everybody wants to be a part of that. So something like this needs to happen in the storage industry. There needs to be a company that comes with something so revolutionary, so disruptive, controllable with an API, standardized, and they need to get bought by someone. Everybody has to go like, shit, we have to do this.
It's called vStorage. You want to take the same example? It's called vStorage.
I think that the danger here, which I think we'd all agree on, is that the problem is that the EMC are trying to position Viper as that actually this is the one thing that will control everything. They'll extend out the plugins so fine it does S3 and Swift and all these other things, and it'll whatever comes along, they'll plug it in, but it's still their proprietary box. There's nothing open about it. It's just an open.
No, and that's the difference. Open vSwitch is open.
It is open,
and that's the funny thing about it. And OVSDB is open. So the idea is that you need to have a company that is open source software that coins this API that we agree on. This is awesome. We should do it, and everybody should adopt it in the open source world. And then the proprietary vendors just have to go like, oh crap, we have to do this.
I think it's called Ceph. I think you're right.
That was cute.
I think the whole movement either have to drive from the vendor. Right now, this is all driving from the vendor, or you drive from the consumer. In telecom, right? The reason they can standardize it because the consumer dictates. They want to draw their price. They said, I want to commoditize you guys. Therefore, to do that, the only way to do that is standardize it. You come up with a standard.
So let me answer this really quick. I'm sorry. So we actually tried standardize management API and control paths, and we failed. And we tried this actually many times. SMIS,
the vendor, right?
SMIS across the vendors, the management across the vendors. We tried this many times.
Because right now it's controlled by the big vendors.
Correct.
The NetApp and all that. Once that industry is controlled by them, there's very little hope to standardize.
So, well, I think that this is where the opportunity is, though, because I think that, and this is the shift, and when we talk about the disruption, I think there is suddenly there's this awareness that actually, yes, these guys dominate, and obviously there's no denying that, but actually there is an opportunity now with software-defined storage, whatever definition you want, that actually doesn't have to be this way. And sure, we're not going to move the brownfield stuff, but for greenfield, of which there is a lot, then cloud is the canary in the coal mine here. And so the bet is that there are going to be more use cases like cloud, for web scales type storage, which goes, just EMC and NetApp are not suitable here. We have to pick something else. If we're going to pick something else, then yes, we want to have standardization. We want to have it all abstracted out. We still want it to be easy, but we want the economics. And I think this is the bet that a lot of us as vendors are making, that is happening. That's happening now. That's why we're having software-defined storage as a term emerging in the market.
Just to that point, just
one thought and suggestion to make is that if you guys can compete with the big consumer today is not a small company, right? All the emerging ones, the Google, the Facebook, the Yahoo, all these big data centers, they have the economy of how to drive it for their benefit.
That's exactly what we're doing.
I think that's happening. I think that's happening.
How many people here aspire to be an Amazon, Google, or Facebook?
Well,
hang on, in the sense that you want to be managing hundreds of thousands of servers. One person.
No, there's more.
The way that these companies grew up was in an era in which I completely agree that nothing else was available. They rolled their own.
Right.
And we're in an age in which we are interested in rolling our own, and I think it's a great thing. Again, if you look at the market over time, part of the reason why it doesn't move so fast is that storage has traditionally been slow because we don't want to migrate, we don't want to change the process. The fact that Citibank still runs, I was telling somebody here, a disk drive that was turned on 45 years ago with 6 megs on it, but chews up several thousand watts at a time, it's because they don't want to change that process. The fact that Goldman runs a piece of software that they know is so bad, but they will buy DRAM solid-state disks to compensate for it. Millions of dollars.
There's that old data, but there's so much new data.
Correct, and I'm not taking that away.
Okay, that's fine. Yeah, okay. I don't think that we're at least trying to tackle that 6 megabyte drive. That's not our market. That's a small TAM, right? What is a large market is the people who are building out. It's like Box, Jive, all these collaboration platforms. Huge market there. People doing software as a service, video applications, enterprise software as a service. Those are big, huge markets.
I think the point he's making is that storage moves slow because we have a huge investment sitting on the floor, and the EMC doesn't come off my floor, or the IBM, whatever it is, it doesn't come off the floor until we're at the end of warranty and it becomes...
Not even beyond
but this is the point.
when you need to change the process.
No, right.
We are doing new things. So you're right. The new apps, Jive, okay, great object store for that, but I'll make the bet 5 years from now on my floor, I'll have some object store, but it's not going to be the bulk of my data.
That's right. So
why not?
So, like for example, with the
because that model is changing at the speed of thought and the speed that developers change, human change.
Exactly.
Not the technology.
It's true. True.
But this is why this is a 10, we're looking 10, 15, 20 years out at this thing. Actually, you're short, the CRM apps and everything else, they don't need massive scale out stuff right now, but over time these apps will change. More of this will move to SaaS, or the other new apps coming into on-premise into the enterprise will need new scale out storage. And I think this is where I disagree about how many people need to run like Facebook and Google. Right now, sure, there's not, it's the thin end of the market, which really wants to be like that. But the point is that what these guys perfect with their software, you commodify, you turn into something that's consumable, that easy to digest and deploy for the average enterprise, which doesn't need a whole bunch of data center admin. You have one data center admin, but the experience and that knowledge has been packaged up principally in the software. That's where the intelligence is, and put on the commodity hardware. And I think this is
to that point, what I thought I was going to have a couple people say, and almost said it was, maybe it's OpenStack, right? I mean, that becomes the de facto sort of orchestration method, at least for those of us who bet on open, as opposed to VMware, although we also, at least in our case, we have to support 8 new APIs from VMware every quarter, and we are catching up and constantly, but also Cinder. I mean, I'll be in Hong Kong as well, as I'm sure you guys will be. So maybe OpenStack will give us, because there is as much stuff going into the hyperscale data centers as all carriers combined. I mean, maybe that will be.
I think what a lot of these guys, at least what I'm hearing, is that you want to simplify the process, you want to unify the process, you want to make it simple and make it easy for the single administrator in that space. There are a couple of things to take into consideration. If that company 15 years down the track is going to be having a single administrator, they're firing a lot of people along the way. Number one, which means that some of you guys in this room won't have a job. Right? Now they can go and become something else, but the IT profession decreases, right?
No.
Number two, if you simplify it down so much, then yes, it's great to have a single piece of software, right? Now you get back into lock-in again.
First off, the rate at which IT can consume it's not going down. Everyone here is going to have a job, and we're doing because we just get more efficient, we get better, we run larger infrastructures, and that spend just will continue to rise.
But what about that's movement towards software as a service? So the number of companies that have moved their emails into, say, Gmail or some other offering, the number of people that have moved their CRM system they ran on site into Salesforce.
You're just articulating efficiency, right? And that means raising standards of living.
Have something to do anymore.
Right?
The IT industry isn't creating new jobs.
It's constantly recreating itself. That's the definition of I don't understand this position.
Space
I can't even wrap my head around it.
you're focused on developing applications, and that's fine. And there are continuing new jobs. There's a difference between that and your traditional IT professional, though, who's looking at this from the perspective that, hey, we just brought in Salesforce. We're turning off the CRM.
They're just going to do more and more. They're going to get more powerful.
Well, one of the things. You're articulating an interesting point. Which we're passing by, and I think it's a totally different point. But I agree with you. The role of traditional sysadmin is changing.
Oh, for sure.
Exactly.
For sure.
And if you don't evolve, you're a dinosaur, and you're going to go extinct. Period. That's what you're trying to articulate. And I agree with that. So you need to evolve.
Sure, but
the reason why we're all here.
That's no different than 5 years ago than 10 years ago.
Well,
I mean, that's the state of our industry, and getting into it, you have to.
There's actually a friend of mine.
Like in my data center, I can do more now with the same people, but there is more to do.
Right.
So it comes both ways. If you told me right now that like 10 years ago, my whole data center was 400 gigs, that's what my data center is today, it'd just been me and one hard drive.
Yeah.
I can do a lot more today, but there's so much more to do. There is Facebook, there's BYOD. So at one point, I'm consolidating staff, and at another point, I have to bring in new challenges. And they don't always balance every week. One year I fire 2 people, and the next year I hire 1, and the next year I hire 2 more, and then they're not in line.
So software-defined storage is more of an opportunity than a threat to your job. I just want to make. Sorry.
But it's also about the point is you're doing more. But I would like you to spend less of your money on the storage. I'd rather you spend the money on stuff which is really differentiating for your business, because actually just storing bits in and of itself is not differentiating thing for your business. And this is the disruptive thing that we can do with software-defined storage. We can actually change the economics by whatever definition we come up with. As long as we're changing the economics, we're moving the money around. This is exactly what happened with Linux. People spent less money on the operating system, less money on Unix. They could spend it more on innovation with the applications. It's at the end state for, I think, what we as vendors, us as vendors on this side anyway, have got to focus on in terms of making software-defined storage for the customer. Benefit for them, they're relevant to the definition here. And this is why I'm saying over 10 years, if we're not seeing a fundamental change in the economics relevant to where we can agree on protocols and APIs and everything else, then this has been a wasted term and a wasted opportunity.
Yeah, I would just second that and say, if you roll the tape back, there's no way Facebook, all these applications exist without Linux, right? And so, fundamentally removing this tremendous anchor on the IT industry should open up opportunities for real innovation.
There's no way Facebook would have existed without HDFS as well, to be honest with you, and all the stuff that they're storing all the photos on. If they've been buying expensive proprietary stuff, they just wouldn't be able to do it either. So we'll see more of that innovation. That's the a very unusual example. We'll see more of that across the enterprise. That's what we've got to try and get to with this term, whatever it means.
Maybe carry on and now flip it back again. Kind of the mirror looking at ourselves. What is missing? Other than all of us consistently saying Viper is not software-defined storage, which after this we will say. But what do you think, Neil? Is it? And we've kind of hit on the orchestration. Maybe it's going to be OpenStack. What else do you think?
I don't think it's what's missing. It's more of about what can we take away to make life easier for the customer. And I think Joe, this has to be whatever definition of and whatever the benefit you're going to get from. I want it to be easy to use. I want you to be able to get access to it now. And actually, this is where we as vendors have got to work with our hardware partners so people can get access to pre-configured boxes, whether it's through reference architectures or appliances or what have you. We're just going to make this stuff easy to consume now. We've got to get the benefit into the consumer's hands as soon as possible. So it's not about features, it's not about optimizations, it's about experience. That's the number one thing for me.
And for me, I think one of the things, and this is the point I do agree with all of you guys on, is that we have to focus on what the I in IT stands for, which is the information. Right? And thinking about innovation, we do spend too much time on infrastructure. And those of you that are IT professionals, I will say that your job is not an infrastructure technology job, it's an information technology job. And as a result, I fully agree with the fact that the instantiation can come in many different ways. I actually strongly believe that the software-defined storage market will have growth, and it will be accelerated growth over the next, towards the end of the decade. And the fact that we can have and consume capacity, which is obviously growing at exponential rates and continues to. And by the way, that concept of data growth is not new to anybody. We've had that same extraordinary experience for the last 30 years. That's not changing, right? So we might be able to store more bits on the same inch. But that part doesn't. Ultimately, the data doesn't change. But we need to focus on the innovation. We need to focus on the information. Right, that's the component, and anything that makes our infrastructure's life easier, to deploy, easier to consume, is going to be in the best interest of all organizations, irrespective of whether you're hyper-scale or whether you're a small business.
Yeah. So we've got about, I think, 6 minutes. We've already had some interaction, but we have about 22 minutes. Yeah, you know where I was going. Question, comment?
Yeah, so another thing I haven't heard yet is traditionally in storage systems, one of the big monolithic systems, you bought stuff that would never ever fail. That's why I bought the big IMCs and the NetApp clusters and everything. But nowadays you've got way different design principles. We don't care if stuff fails. We're not scared if it fails. It's okay if it fails. And I think software-defined storage is just a new technology to facilitate a new design principle.
I think we are looking at a much more good enough type approach, although at the end of the day, failure to get access to your data is never a job saving.
Sure, but the question is, to paraphrase, is we're moving availability and robustness up the stack into software.
Yeah.
A, is that true?
Well,
and B, is it going to happen so much so that storage guys are out of a job because it's all going to be DAS, and the application is going to be so brilliant you don't need us?
Yeah, well,
to extend the point.
I think yes, but what we were actually talking with some like a traditional storage vendor, and they were just baffled by that concept of, whoa, you're going to route around a failure, a node goes down, and that's okay. To them, it's like, we've just spent the last 20 years figuring out how to predict failure so it doesn't happen at all. And now you come in walking in here and saying, yeah, we'd throw cheaper equipment at it and then route around the failure. So then that was a really kind of a challenging thing. But in practice, it works that way. And if you can scale out the environment enough, you really can just, stuff does fail, we expect it to fail, and route around it.
Actually, it's good when it fails often, because you know what the hell you need to do with it when it fails often.
And don't run down to the data center.
Yeah, because it's normal that it fails.
Normal. Okay, all right, so we're getting durability is recovering, and we're on our way. We can decide what to do later about that.
So design for failure is another piece of the definition.
It's definitely a trend. If I look at us as a company, we're a mission-critical outsourcing company. We guarantee 100% functional uptime on application landscapes. And we're actually moving to the space where we're saying, screw this monolithic old bullshit. We're going to move up the stack as far as possible and design everything for failure up there, instead of going like, we need a metro cluster, we need synchronous mirrored storage, we need to have HA stuff in place. Get rid of it.
Right.
I think
that's the whole, like, the concept of going towards, at least the way we think of it, is around the eventual consistency model. And unfortunately, that means that an application has to be aware of that and built around that. But the benefit of that is that you can be a bit more, you can distribute data, and as long as the application is aware of that, you can get way better availability.
Yeah. And Joe's absolutely spot on. Distributed fault tolerance is a critical element, and you can lift it all the way up into the software layer if you want, so long as you write the apps for it, right?
Well, the apps just have to understand that they're communicating to an object storage.
The apps have to be written to that, or whatever the middleware is that you're using.
Yeah. Not necessarily, but no.
Set is middleware.
But the other element too is that monolithic storage has a very limited application. And we have to decide whether we want the fault tolerance to be done at the hardware level or at the software level. We want to understand and make a decision, and we have the choice today of whether we want to aggregate and abstract on a hardware level or a software level, or both in some cases, right? I'm not sure if you were in our talk yesterday with Evan, but I did make one observation that disk drives are designed to fail. We make components that are designed intentionally to fail, right? And therefore, the elevation of that fault tolerance is just a different approach to doing something that Dr. Philis and et al. At Berkeley solved when they wrote the RAID paper. Right?
Can I ask this panel, is Google one of your customer at all? The reason I ask that question is that I kind of echo whatever his view is from a news type customer. I heard Google, they commoditize the hardware, and their disk is so cheap, their drive is so cheap. What they do is it's fail. They don't even bother to be paid.
They do not. That I know for a fact. Yeah.
That's our strategy with our systems is you have an option.
That's what we're all seeing.
A drive failure happens, and you decide what you want to do. You either do nothing, or if you want to just carve it out, you click a button, and away you go.
I think
They reroute basically.
Yeah,
exactly.
Well, the system automatically reroutes. That's even before an operator gets involved.
But I mean, this is the point about the economics. It's cheaper to do reliability in software than it is in hardware. That's the essence of the point here. But also, I think it's
Also safer, right?
It's
If the hardware fails, it feels spectacular.
so. This is
A lot of implications.
that's right. So I think this is. I don't know if you saw there was an article by the NetApp CTO yesterday in Forbes going on about this. That why hasn't open source disrupted? Have you not read this?
Please elaborate.
Why hasn't open source disrupted the storage industry? And his point was, well, open source, it's very good at getting lots of computer science people to work out how to solve problems, but it's not good at solving engineering problems, and reliability and robustness is an engineering problem. And I think that's true when you're looking at things as a hardware problem. When everything becomes a software problem, it is a computer science, it's a distributed systems problem, and it's not easy, but it's much easier to fix those problems, and it's certainly a lot cheaper. So I think, again, this is why when I said in my definition of software-defined storage, I'm adding in, it's not a common definition, but I do think the distributed nature is a critical bit. This is why there's a new thinking, there's a new approach. You may not think it's as revolutionary, and you can see it in other areas, I agree, but this is the bit that's changed now. It's a distributed systems problem we're dealing with here, and it's all software. It's all in software.
I actually would agree with this because
NetApp is
before
that's complete BS, by the way. I mean, I know for a fact we have disrupted the shit out of NetApp. But go ahead.
So actually, but the point I would like to make is that we actually tried to do distributed file systems before. Probably what we can name like maybe 10. 20 of those, even open source ones, but only few of those actually survived as projects. So the reason is, we know the reasons, because actually, I agree with you, Ben, we're designing disks, we're designing SAS SATA buses for failure. So we need to make sure failure needs to be observed, failure needs to be handled in a proper way. Without this piece, we will not be able to do good distributed systems anyway. The consistency is another concern, but so if it's about use cases. I actually big believer in distributed systems. At Nexenta, we also adding, in addition to file and block, we adding object story as well next year, and I think it's a disruptive technology. But what unites us here is that I think we generally agree it's a software agnostic side of things. This is what EMC cannot do. This is what NetApp cannot do, right?
Well, they can do it, they just don't want to.
Exactly. Well, actually, if you look at NetApp, they use FreeBSD and they ported Waffle to it. I mean, they're not doing anything really special if you think about it. But they're selling it as like a monolithic box you can buy, and that's it. They
can't do it because they have their whole sales structure is oriented around selling their systems. Right? They just can't disrupt it that way.
No, exactly.
At all.
More questions from the audience, please.
So when you look at virtualization works for my company, for smaller companies, for big companies, for the cloud. Yes, there's Zen, yes, there's Hyper-V and everything like that, but the concept, I'm wrapping this product up. But when I look at software-defined networking, when I look at software-defined storage, VMware bought a company that came out with NSX, but you know what? You can only have it if you're Fortune 500 right now. You bring up Citibank, all these other people. I love the idea of Ceph, Swift, everything like that, but I feel like today there's a different software-defined storage for the cloud, for the extremely large enterprises. How do you, like virtual machines, make it disruptive by bringing it into companies my size, smaller than my size? I mean, I know people that are running a single ESX host that have 10 VMs. It's not disruptive until it can hit that whole stack. Just like you were saying, Viper doesn't go to the cloud. If the cloud doesn't come to me, then it's not.
Well, I mean, that's a great question. I mean, I think you can stand up these environments, and ultimately what we're seeing people build is they're building out storage services in their organization. And then what they're doing is they're putting multiple users on those storage services. And to that extent, we see more consolidation of the amount of data that's being put in place. And when you can go out to your organization and say, hey, here's a storage service, I'm going to account for that application or that user and how much your storage, so I can do chargeback and things like that. That's what you're really lighting up when it comes to building out these private, I hate to use cloud, but private cloud storage infrastructure. And does that fit into the software-defined storage definition? I don't know, but that's in effect what you'd be able to, where you can do today.
Viper and Nexenta, what they're doing, the stuff you guys are doing, hey, we want, but it just, like you said, there's the scariness.
It's the experience, isn't it?
Obviously,
I mean, look, I mean, the stuff that we have, I mean, open source is sometimes a scary thing because the amount of configuration involved. And what we can do with products that you put around open source is you can make it super easy to install. I mean, Nexenta, we're doing it as well, where it's just one-line command install, and then you have a GUI that can assemble a distributed system together. You have a little dashboard where it has your logo, so you can present to your users. I mean, stuff like that. It makes a big difference, and that's the goal that we have as a company to try to enable. So we are trying to bring it down to, I think, that level.
And you guys are, not talking petabytes, but just talking a couple of terabytes. Are you moving into that Inktank, SwiftStack? Are you getting into the virtualization? They might have started up here, but they've spread in every direction.
Yeah, I mean, we certainly have customers come to us who are under 25 terabytes, and then the ones that we go after are hundreds of terabytes, obviously, right? In terms of where we spend our energy, marketing dollars and going out. But certainly self-service off the website, people come on and we have random MSPs all just coming on.
Yeah, I mean, the point here is even if it's 25 or 50, the point is when you double that, you want that to be easy. Correct. And you want it to be resilient and everything else. And when you double it again, that may be a year, 2 years, but as long as that takes you a couple of minutes rather than a couple of weeks to expand it out and rebalance data, which is the promise of this software, it totally will benefit you. Again, this is why it's a conveyor belt that comes from these big guys who do it at scale, package it up, make the experience really, fantastic, and then you get the benefit of that same, just easy, don't worry about it when things fail, but when you need to grow it, it's a trivial operation. And I think, this just I want to echo what Joe said. Actually, this was the talk I was planning to give yesterday until Ben Cherian took my spot. This is just, we've had over the course of 10, 15 years in open source, we've seen it came out, it was, wow, it's incredible, it's really impressive, oh my God, no one can use it without a white lab coat. And the companies come in, they make the packages and make the experience. It goes to the big companies first, where they're going to make the money to invest in the business, grow the business, and then bring it down to the SOHO and the SME business. And I think this is the bet that I know Joe and I are making in it with open source storage now. Is that that same process is going to happen now, finally, in the storage industry.
So if you guys, that's a year away, or that's like the new CEO?
Give me your business card, and we'll get a sales guy talking to you. That's not a problem. Don't worry.
I think for all of us up here, I mean, it is today. Okay. And we certainly have customers that are. We're not doing anything. It's like, oh wow, that just happened. You probably remembered way back when you got to that point.
Right.
It's kind of a neat thing to start to be able to say. Yeah.
So what might be useful along these lines, because you're starting to talk about how would I use this, is the point was made that we touch different use cases, or we touch a lot of use cases, but we're probably best at certain use cases. Do you think it'd be useful, just quickly, what's your top use cases, and we'll just hit it?
So backups, archives, log files, documents, video. I would say that'd be our kind of our sweet spot is right now.
Good question. The first ones were all big streaming data, and then
Yeah.
the web browser, it's going to be really, really.
Yeah, so some people, what they do, so the specific problem that we handle is lots of concurrency related to that. So like consumer devices company, and every day each one of those things phones home, deposits a little log file. How do you handle the concurrency of 1 million requests throughout a day? That's the problem, and then those get shipped off for processing. We don't necessarily have the processing on the box.
So from an Inktank point of view, we're focused very much on the object and block side of things, and so that's why we've seen a lot of success in the OpenStack and CloudStack markets, where we're doing both the block for the VMs, so very similar to the configuration that Intel put together. Just whatever application you're running in LAMP stacks and so on in an OpenStack cloud. On the object, again, we serve just as Swift does. We're an object store for your cloud VMs, your snapshots, and everything else. But also, yes, we do large media files for media companies and the archiving and backup. This is obviously the sweet spot for object storage right now. But Ceph as a project, because it does the file system as well, people are using that for everything and anything, whether it's file serving, HPC, Hadoop alternative. It can, it's a general purpose file system, so the use cases are infinite. But Inktank isn't focused on that market yet.
I think.
Sorry, Dmitry. Just quickly.
So what we actually, I think the top use cases for us is enterprise NAS, and I really mean enterprise grade NAS. We have NFS, CIFS unified protocols, which really the criteria there for the use cases is availability and reliability of the system, as well as consistency. And we do see backup archives. However, we actually seeing quite a bit of hosting, cloud hosting deployments. They use us as a backend for the object systems as well. High performance systems, the design with which you presented is one of the designs which are also very popular at Nexenta. Mission critical applications, so that's what we are focusing on.
Yep, thanks.
I don't think there is any application or workload that software-defined storage couldn't handle. I think that the great thing about it, and an area where talking about the greenfield opportunities you suggested, is that there's a lot of growth in unstructured data of any sort. Right, and every sort, and I think those open up brand new opportunities for a number of reasons. One, it's the 80% year-over-year CAGR that's growing at. Number two, they're spawning new opportunities and new applications and new methodologies in terms of how to deal with it, which means that you need to match that new approach from the app down, including your infrastructure, to make sure that it is all coherent and optimized for those new wave of applications that are coming through. So, but as far as the theory goes, and as far as the implementations that I've observed in across all industries, there is no reason why software-defined storage vendors and solutions couldn't be deployed in almost every situation I can think of.
It's very broad. Quick one might be, and now we are down to just a handful of minutes, so if you've been holding on to your question, get the hand up. But is it important or germane or to be able to run as a VSA, to run on VMs? Because, or not, is it a niche? I mean, will the controller migrate on as yet another application that is itself running in a virtualized environment?
We have customers who are doing that more in the test dev, but when they start scaling up, they certainly almost always move to dedicated equipment.
Yeah, absolutely the same experience here. The storage grows much faster than the compute. You want to keep it separate, but where possible.
Yeah.
Similar, we do see a need in running storage as a VSA as a cache device.
Right. Yeah, there's the caching is the area that software-defined storage has got to get a lot smarter at in terms of how it handles it. For sure.
What do you think?
Well, actually, I think there are both use cases for virtualizing it for like VSA purposes. You see some devices come around that do that, some do it well, like Nexenta, some do it not so well. But at some point you cannot virtualize everything depending on your load. If we look at the right I/O heaviness of our environments, it wouldn't make sense to virtualize that because you'll just be killing
Everything
your
else.
virtual box, everything
Yes.
else on the box. So that wouldn't make sense. So definitely, it's a mix and match depending on your workload and what you're trying to achieve.
Yep, exactly. And that's exactly what I was going to say is like your workload is probably going to dictate whether or not you can do it. And if you can get the cost efficiency from moving to a VM, do it.
Yeah.
Right.
True.
Yeah, from a software-defined perspective, it gets pretty interesting, right? Because the points you're making. And so what if your performance drops? Should you try to take more resources? Or does that mean, holy shit, we should reduce the resources we're taking because that must mean the whole host is getting pounded?
Yeah.
And figuring out how to get the storage to adjust to performance at the host level is, as Dmitry knows firsthand, non-trivial. So we tend to focus on a couple, really VDI today. A couple use cases.
And of course, you can choose to scale out your VMs and stuff, but sometimes at some point it just doesn't make sense anymore to scale out your VMs and just move to Iron again and do it that way. So it really depends on how big it gets.
Right.
And
Absolutely. Okay, so we had some violent agreement and disagreement. Anyone else care to try to cause some more of either one of those? Yes, Kevin.
So I think that, when you talk about consuming this stuff, maybe y'all are missing the boat with this, because at least what I think I'm hearing is that, well, up front y'all said separate data and control plane or management plane. Totally agree with that. I think from a software-defined storage, I don't think my EMC and my XIV storage arrays are exempt from this.
And they shouldn't be.
When I think software-defined storage,
And they should not be.
I'm thinking automated provisioning,
Yeah,
very simple, maybe even consumer provisioning, where they just said, I need 5 terabytes added to this app, and bang, it just all happens.
but that's what I initially said. That's what I mean with the control plane and unified API with policies, and that you can push every type of storage underneath that. Have your merry way with it.
And Dimitri's comment earlier about SNIS, I hadn't even thought about that when we started talking about this, but that's exactly, you had large vendors embrace it so they could make sure it was inadequate so it would go away.
Yeah.
I think that's the challenge now, is to not let any invested players in here, right?
Yeah, I know the path that we've been going down. Like we've been working with Seagate on the kinetic drive, so we have that stuff coming up. I'll talk about that in a bit. But being able to abstract what's underneath the file system for us, because we're just storing bits, right? Ultimately, it comes down to storing data somewhere. And today we carve out storage so that we're storing data on specific drives. Hey, and what if we can figure out a way to have a volume which we know is backed by something that's designed not to fail, and then we have different replication policies, and maybe we think about doing it from across region instead of in data center, have lots of replicas to preserve the data, because we know we're putting it on a more durable, if you will, design to fail system.
I can consume a small part of that this year and a little bit more of that next year, but I think where this really changes is if it's something that's more widely consumable now.
Right.
I think that you're going to find more and more platforms that will help to unify all of that, and certainly even from the Nexenta's perspective, they offer opportunities to do that. But I think at a control level, products are out there to do exactly what you've described. The question comes down to, do you want to lock yourself into that product, which may be instantiating software-defined storage in an appliance, which means that you're remapping everything to that appliance, or if you wanted to take a much more open approach. The evolutionary concept is extraordinarily important in that you're not going to take what you've got today and throw it out. These guys, I don't think any of you guys are suggesting to do that. No. Well, you might want them to, but it's more about how do you plan for the future? What are your applications going to look like in the future? Are they going to be more web-like or 2.0-like, right, or not? And if they are, then you need an infrastructure that can marry well with that environment.
That also speaks to performance, which we didn't get into too much. Yeah. But we actually are out of time. So what I'd like to say is, again, thank you to the panelists, and thank you all. And I think today it may seem that software-defined storage is a niche, but I mean we have thousands of deployments, and I can tell you with absolute certainty we've taken a gazillion petabytes out of messes pockets, and I think that's happening today. There's real companies, real customers, some of whom are in the audience and very smart about this stuff, changing the way that data is stored. So it's a really exciting time, and thank you for the violent agreement. We may write it up and try to, you know, I don't know, say something about EMC, although I've been told not to bash EMC so much. So just for the record, I didn't say it's lipstick on a pig. I said, aren't you saying it's lipstick on a pig? I didn't say that. But in short, in all honesty, it's
I described it as a storage mullet, right? Blog, is that
I do not hold the
a
position.
storage mullet. Storage mullet is catchy as well. So thank you all. A round of applause for our panelists.